So these notes we're going to take today are on flat mirrors, and this will be a quick introduction that we can use for what you'll be observing in our mirror lab that you'll be doing shortly. And so if you don't have some lined sheet of paper out to take some notes, please pause the video and give everybody a second to pull out their notebooks or to pull out a lined sheet of paper for notes real quick. And when you're ready, we're going to title these flat mirrors. And so after learning about the law of reflection, we're going to be looking at different types of materials that use the law of reflection to do certain things. So one of the most common ways to observe the law of reflection in real life is with mirrors. So with mirrors, light doesn't pass through the mirror. It hits the mirror, reflects, and bounces off. And depending on the shape of the mirror, it does reflect, bounce off in a particular way. So flat mirrors are the first to kind of understanding how that reflection looks before we get to mirrors that are curved, where their images that are made and how they reflect light is a little bit different. So you'll be working today with flat mirrors today, kind of the most basic mirror. And in particular, we're going to be focusing on the images because in the little bit of like digital lab work that we've done so far, your image that's formed in a mirror is due to the law of reflection. So how the light reflects, bounces off of the mirror. Images and flat plane mirrors. And so by a plane, we mean just a mirror that's just completely flat, like what you would stand in, what you'd be looking in the bathroom, most of you, or a window. It's just a flat mirror. So when you stand in front of a mirror that's flat, you should see that you are the same size, or the image are the same size as the object. That's partially why we use flat mirrors specifically, is so that we can visually see our relative size. So flat mirrors don't make the actual object look larger or smaller than what it's supposed to appear. So images in a flat plane mirror, they are the same size as the object. They have the same position. We're going to say, quote unquote, in or behind the mirror. So your image in the mirror has the same position in or behind the mirror. So when you look at yourself in a flat mirror, it looks like you're projected inside of the mirror a particular distance. And so by same position, it means it should be the same distance away. So for example, if you are 3 feet in front of the mirror, your image will look like it is 3 feet inside, or if you want to use the word behind the mirror. So depending on your position in front of the mirror, your projection, so what your image is going to look like, is going to be the same distance behind or inside of the mirror. So if you notice, if you walk closer to the mirror, your image is closer to you. If you walk farther away, your image is farther away. So we don't see a relationship where if I walk backwards, my image moves forwards. So the projection is the same distance away. You've also probably noticed, but maybe never thought about it, that our image is upright. So the mirror doesn't take your image and flips you upside down. There are some mirrors that do that based on how they're curved, how they're shaped. So for the most part, an image in a flat plane mirror is exactly what you're going to see in real life. It's upright. You're the same distance away from the mirror in the image as you are actually. You're the same size. The only difference is orientation. And that's going to be based on your position. The orientation is what we describe as being left, right reversal. So your orientation is left, right reversal. So a couple examples of that. If I raise my right hand, to me, based on my position, image looks like it raises its left. So you put your right hand up, the image projected will look like the left hand is raised. Or this might be even more noticeable if you're ever wearing a t-shirt with letters on it. So for example, if your t-shirt says physics on it, and you go and stand in front of the mirror, again, your image is going to have this flipped from left to right. So the letters will still be in the same order, but going from a left to right, or it'll be flip-flopped, I'm sorry. So your physics now will have your letters going the other way, and you'd be reading it then in the other direction. So what you're going to be doing soon is a lab that it's going to look kind of long, but there's a lot of pictures in it and a lot of little things to do here and there within it, along with the instructions and stuff. But we have a lab where you're going to do a bunch of different observations with the law of reflections and flat mirrors, and so how those flat mirrors produce an image using all of these concepts. This might go into a second day, and so if it does, that's fine. You're not going to be expected to take the mirrors home for homework. It's just something that we'll be continuing on the following day. That's it for our notes, though, and I do have another video in Classroom that we don't need to show today, but just if you're looking for some reinforcement on mirrors, since I am not here today to answer those questions. Hopefully then that YouTube video can clear that up for you.